Hi, I'm James, and today I'm going to talk about the Physics Nobel Prize for this year. The Nobel Prize is a prize established by the famous Swedish chemist Alfred Nobel over 100 years ago. This prize is given annually by the Royal Swedish Academy to those who had provided the greatest benefits to the mankind in 6 different fields: chemistry, peace, economic science, medicine, literature, and physics. This year's Physics Nobel Prize are split among 3 people. Arthur Ashkin for his invention of optical tweezers. Gerald Moreau and Donna Strickland for developing the high-intensity ultra-sharp optical pulses. Both of these achievements are really advanced and not exactly 8th grader friendly. So today, I'll only talk about Ashkin and his optical tweezers. Arthur Ashkin is an American scientist. He received his PhD in the Cornell University and is currently working at the Bell Laboratories and Lucent Technologies. He is most well known for his development of optical tweezers, which won him the 2018 Nobel Prize. So, what are optical tweezers? Basically, the optical tweezers are 2 columns of light which can trap the small particles and move them around, left and right. To understand the science behind this, we must first look at how are things moved in the first place. Now, according to Newton's third law, when you push an object, it'll push back with the same exact momentum. So in theory, with no other net forces, when you throw a ball towards a stationary box with 0 momentum, the ball will push the box back, of course, but at the same time, the box will push the ball back, so the ball will just bounce backwards towards the way it came with the same exact speed. This all looks pretty good, but the only problem is that in physics, when an object delivers its momentum to another object, the sum of the transferred energy should be exactly the same as the given ones. In this case, however, it seems like the momentum of the sum of the balls bouncing back and the box going forward are twice as many as the original momentum of the ball. So is physics broken? Now, the reason for this is because in physics, momentum is a vector quantity. Both direction and magnitude matters here. So, when the ball bounces back, it has a negative momentum and the box has a positive one. When the ball hits the box will have to use the same momentum to stop the ball from moving and another to push the ball back. So in the end, the sum of these 3 momentums are the same. Now, what does this got to do with the optical tweezers? When you shine a light on the mirror, it is the same as a ball hitting the box. The light is pushing the mirror and the mirror is pushing back on the light, causing it to reflect. And when you do this on lenses, it only pushes it left or right. Now, imagine if you can cover the whole lens with light. It will be a force on the right and there will be a force on the left as well, pushing the subject right into the middle. In this case, when you try to move the object away from the middle, it will move back because of the net force acting on it. Now here comes the most important part. If you decrease the amount of light on one side just a little bit, you break the balance of the net force. Your whole light will move to the side that is decreased, pushing your subject with it, causing it to move together. So that's basically how the light tweezers can change the position of an object. This research is not only a pioneering work in our study of lasers, but it can also be used in a lot of different fields. For example, in the medical field, this technology can be used to move tiny cells and viruses, and in biology, fact, it can move the DNA groupings and even sometimes regroup them. All in all, this is a really awesome invention, and I think it won the Nobel Prize fair and square. Thanks for watching.